So I have another game here in the Ask Marilyn column, and this is called Chuck-a-Luck, and we have that um, Daniel computed the probabilities incorrectly, but we have a correct table here with the correct probabilities and the profits here, and we want to answer some questions about them. So the first one here is we want to verify that we have a discrete probability distribution. So here you can see in Chapter 6 we are working with discrete probability distributions, and then we'll continue on to work with continuous probability distributions. So what we want to verify here, again, is those two conditions, that all of our probabilities are between 0 and 1 inclusive. So by inclusive we mean that 0 and 1 are in fact possibilities. So here we have values that are between 0 and 1, so we're good. And then our second condition here is that the probabilities need to sum up to 1. So if we add these together, so they're all on a 216, so I'm just going to add their numerators. So 125 plus 75 plus 15 plus 1 here. I get 216. 216 out of 216 is 1, so we're good there. So part B, we want to compute and interpret the mean of the random variable. So be careful here what you're putting in there. So we're trying to find the mean. So we're trying to figure out what is our profit over time. So that's what we're working with. So that's going to go in L1. And then our probabilities are what's going to go in L2 this time. So we're, again, going to do one var stats, L1, comma L2. Or if you have a calculator that pulls up a menu list, your list should be L1, and then your frequency list there should be L2. So let's go ahead and type those in. So again, I'm going to do second plus 4 to clear out my list. Stat, enter, go over to L1 and type in my profits. So negative 1, 1, 2, and 3. Go over to L2, 125 divided by 216. Again, it'll convert that to a decimal, and that's perfectly fine. So now that I've did that, I'm going to click second, no to quit out, go into stat, go over to calc, and enter for one variable statistics, second 1 for L1, comma, second 2 for L2, and then enter. And we're looking for X bar, so we're going to round that there. And our symbol here is mu sub X because we're working with a random variable X. So that is approximately equal to, and we're talking about money here, so negative 0.08. So we're looking at losing 8 cents. So now we want to interpret the mean here. So what we're going to say is that if you play the game for a very long time, you will lose approximately 8 cents per game. So you kind of see that we're talking about over an extended period of time. So part C, we want to compute the standard deviation of the random variable. So that's our calculator there. Type in here. So this is going to be sigma sub x, and that's going to be approximately 1.113. And then the variance, that's going to be sigma sub x bar squared. So I'm going to do bars 5, and then 4 is my sigma sub x, and then I'm going to square that. So 1.239. Moving along here. He asks, what's the probability that a player who plays once will lose the game? So in other words, what is the probability the player will match none of the 3 dice? So this is number of dice matching the chosen number. So we're looking at none of those here. So that's the probability that the matching none, right? So in this case, we will get 1, 25, 2, 16. And then the next question, we want to match all three. That's the probability that we match all three. That is 1 out of 260. And then G, we want to know what's the probability that they will match at least one. So that's going back to the previous sections there. Remember that at least probability. So at least one. So again, it's 1 minus the opposite. So in this case, the probability that they will, the opposite of matching at least one is matching none there. So that should be 1 minus 125 over 216. So we are looking there at 91 out of 216 as our probability that they will match at least one of those.